Moving on from simplifying, we're going to be looking at multiplying and dividing rational expressions. The process is very similar, we're just adding in an extra step. When we want to multiply fractions and rational expressions, keep in mind that all we do is we're multiplying the numerators and the denominators. When dealing with rational expressions, we often want to factor the numerators and denominators first. And then when we multiply, we're just creating a longer list of factors for the numerator and the denominator. So let's take a look with our first example. And we start just by looking at what expressions we can factor. Our first numerator is already completely factored. But keep in mind, since our variable is second, we can use our commutative property of addition to rewrite it in a different order, which may come in handy later. So always keep that in mind. Our second numerator is a binomial, but it only has a GCF. So if we go ahead and factor out the GCF of 2, we're now left with 2 factors in the numerator. Our first denominator is just a monomial, so we can't really factor anymore, but keep in mind that 2 and n are separate factors. Then we want to factor the trinomial that's in our denominator. And so we'll use our product sum process. We're looking for a product of -3 with a sum of -2, which is our b value. And the numbers that give us that are going to be a -3 and a +1. So we can rewrite our equation as 3n squared minus 3n plus n minus 1, and use factor by grouping in order to factor the polynomial. Since our second grouping is already the n minus 1 binomial, we just need to factor out the +1. So our second denominator factors to be 3n plus 1, and then n minus 1. Now when we're multiplying, we take the numerator and we're just combining all of the factors together, and we'll do the same thing with the denominator. Do not bother distributing, however, because that's just going to undo all the work that we already did. So we take our 3n plus 1, it's being multiplied by 2, and also being multiplied by n minus 2. Those are all the factors in our numerator. Then we have 2 times n being multiplied by 3n plus 1, as well as n minus 1. Those are all the factors from our denominators. So we can look to find common factors that exist now within the combined numerator and denominator. We see that 3n plus 1 is common in both, as well as the integer of 2. So we're left with a numerator with n minus 2, as well as n and n minus 1. Be careful when trying to simplify further. It looks like there might be a common factor of n. However, in our numerator, since 2 is being subtracted, n is a term and not a factor. So we need to make sure that we keep it grouped so we don't accidentally simplify something that can't be simplified further. We take a look at our next example. Our first numerator is a binomial, but notice how we have a third exponent, and we also have a perfect cube in the binomial, giving us a difference of cubes formula. Recall our difference of cubes formula. If we have a cubed minus b cubed, it factors to be a minus b, and then the trinomial of a squared plus ab plus b squared. If a and b are x and 1, which is the cube root of both terms, then our trinomial will be x squared plus x plus 1. So our first numerator is now factored. We look at our second numerator, it's already a monomial, so there's not really a lot here, but keep in mind that we could break apart 15 into 5 and 3 if we needed to simplify partially. Our first denominator has a GCF. We can either factor out a 3 or a -3. Often if we have that negative for the first term with the variable, it's better to factor out the negative GCF, which will change the sign on both terms within the remaining factor. And we look at our second factor, x squared plus x plus 1 is prime and we can't factor it, but notice how that's the same trinomial that we got from our difference of cubes. And so we'll be able to simplify those in a minute. So we go ahead and just combine all the factors in all the numerators and all the factors in the denominators. We look for common factors, such as x minus 1, and our trinomials, and then we've got 15 and -3. Since the 15 can be rewritten as 5 times 3. We can simplify the common factor of 3 that exists in both places. So we're left with a negative 5x squared over 1, which reduces to just negative 5x squared. Now with dividing, it's going to be very similar, but just recall that when we're dividing fractions, we need to multiply the numbers by the reciprocal. And so our second fraction will flip the numerator and denominator, and then we'll follow the same process for multiplication. Whether you factor before or after the flip is up to you. I often recommend doing the flip first so that you don't forget after you spend the time to factor. So with our first problem here, we're going to go ahead and rewrite it as the product of the reciprocal. We change our division to multiplication, and we flip the numerator and denominator for the second fraction. We'll go ahead and look to see what we can factor. 8m squared, we'll leave that alone as the binomial. It might be useful to rewrite 2 minus m by factoring at a negative 1, so that we have m minus 2. Then we'd go ahead and look at our denominator. We have a GCF in this binomial, leaving us with m squared minus 4. And because we have a difference of squares, we can actually factor this even further. M minus 2 and m plus 2. And so the product of all of our numerators, we have 8m squared times negative 1 m minus 2. And then the product of all our denominators, 3 m minus 2, m plus 2, and 40. We can go ahead and look for common factors. We see that we have an m minus 2 that's the same. And then 8 and 40 share a common factor of 8. 40 can be rewritten as 5 times 8, so those 8s will reduce, leaving our numerator with m squared times negative 1, and our denominator as 3 times 5 times m plus 2. A little bit of a cleanup step, giving us negative m squared over 15 m plus 2. Notice if we have integer factors left, we'll go ahead and multiply those, but we don't distribute into any polynomials that are left. This one's going to take a little bit more time to factor, so we'll take it step by step. Let's go ahead and rewrite the problem as the product of the reciprocal. So we leave our first fraction alone. Change our division to multiplication, and we write the reciprocal of the second rational expression. Now we can go ahead and factor. Since all of these are trinomials with leading coefficients, we're going to do our product and sum for each of those, starting with our product of negative 36, and we want a sum of 9. The numbers that give us that product are going to be 12 and negative 3. And so we can rewrite this as 18y squared plus 12y minus 3y minus 2. Use our grouping. And we end with 6y minus 1 and 3y plus 2. Then we can move on to the next set. Product of 24 with the sum of negative 10 for our first denominator. That gives us the numbers of negative 6 and negative 4. So we can rewrite 24y squared minus 6y minus 4y plus 1 and factor by grouping. Leaving us with 6y minus 1 and 4y minus 1. Moving on to our second numerator, we're going to have a product of negative 40 and a sum of 18. So we'll use the numbers 20 and negative 2. to rewrite 8y squared plus 20y minus 2y minus 5. So we end with factor out of 4 and a negative 1. So our factor is 4y minus 1 and 2y plus 5. And often as we do this, you'll find that some of the factors start repeating from earlier polynomials. And then for our last denominator, product of 30 and a sum of 17. That's going to give us the numbers 15 and 2. So 3y squared plus 15y plus 2y plus 10. Leaving us with factors 3y plus 2 and y plus 5. So now that we have everything factored, we can go ahead and combine all the numerator factors and all the denominator factors. 6y minus 1, 3y plus 2, 4y minus 1, and 2y plus 5 for everything in the numerator. 6y minus 1, 4y minus 1, 3y plus 2, and y plus 5 in the denominator. We look for the common factors, 6y minus 1, 3y plus 2, 4y minus 1, leaving us with 2y plus 5 over y plus 5. Here we have multiplication and division. So we'll go ahead and rewrite the division portion as multiplication of the reciprocal. That way we don't forget later. So the first two fractions remain the same, but we'll go ahead and flip the second and rewrite as multiplication. Then we can go through and factor. Our first numerator is a difference of squares, so we have x plus 5 and x minus 5. And its denominator is x plus 5 twice. Multiplied by, we can factor out a GCF of 3, leaving us with x plus 5, or 4x. And the last one, the denominator factors to be x minus 5 and x plus 2. We can now go ahead and just treat this as one giant fraction, since we're multiplying all the numerators and denominators, looking for common factors. We've got x plus 5s, that'll cancel here. And we've got x minus 5s, that match up and cancel here. Then we actually have another set of x plus 5 here and here, so those will cancel. And we have a matching pair of x vectors here and here that will also reduce. So in our numerator, we're left with just 3. Our denominator, we're left with 4 and x plus 2. Lastly, we can also use our rational functions in different applications. So take a minute and read through this question to think about what's being asked for and how we're going to use the information that's given in order to solve. So here we see our cost function given by c of x, and we want to evaluate the cost of pressing various compact disks. Our independent variable x represents the number of compact disks, and we're starting with trying to figure out the cost if we press 100 disks. So we'll evaluate the function c of 100. Anywhere we have an x, we will substitute with the value 100, and then we will simplify and evaluate. So we end up with 260 plus 10,000 divided by 100. 10,260 divided by 100 gives us 102.6. And since we're dealing with cost, which is money, we want to automatically round to 2 decimal places. We'll do the same thing again to evaluate the cost of pressing 1,000 disks. We'll evaluate C1000. So we have 2,600 plus 10,000, which equals 12,600 divided by 1,000, giving us 12.6. Again, since we're dealing with money, we want to round to 2 decimal places, $12.60.